Hi, this video is going to cover geometric transformations using matrices in section 12.5 of Algebra 2. So let's look at those transformations again that we've learned the last couple years. The first one is a translation. That's where you move without rotating, right? So you're moving left and right and up and down. So you're either adding or subtracting to that x value or that y value. So you're just going to take that shape. It's going to stay just like it is, but it's going to move around. So it will stay in that same shape. So or that same orientation. So for example, if I have this shape here and it's like this, it would be moved around up, down, sideways, but it would not like rotate or do something else because that's not a translation. The next one is a dilation. That's just where you're going to have a scale factor and you're going to multiply by making it bigger, multiply by a whole number, or you're going to multiply by a fraction and reduce and make it smaller. And in the matrices, it's going to be scalar multiplication, so you multiply all x's and y's by a number to make it bigger or smaller. For a rotation, it's a lot more complicated. So a rotation, as far as with the matrices and in general, I'm going to take this and I'm going to rotate it around a point. So if my point happens to be here, and this one, I'm going to get a new one out. That one happens to have like this little ledge, like it was like half cracked on the end. Okay, so if I am rotating around a point, maybe I would rotate this 90 degrees and it would now be here. Okay, so it would go from here to there, and maybe that's 90 degrees. It looks like it is about 90 degrees. So the main rotations that we're looking at, so let me read my definition that I wrote out. A rotation turns a figure about a fixed point, and the fixed point is that center of rotation. You can multiply a figure's vertex matrix by a rotation matrix to find the vertices of the rotation image. And we go counterclockwise for this section. So we're going counterclockwise on our rotations, counterclockwise. And I just did clockwise, counterclockwise. Okay, so here are our rotation matrix. We are actually going to, here's 90 degrees, so you want to make sure you write these down. This is 180, this is 270, this is 360. So if you need to pause it and write it down, do so. Pause the video. So these are what we're going to multiply our matrices by that has our points in order to get the new points of 90 degrees. And it's super cool. I can just like multiply and I've got the new matrix. So, or the new points. It's kind of a cool way to do a rotation. Otherwise, the only way I know how to do a rotation is with a compass and a protractor. Okay. So a reflection is a mirror image across a line. So the typical lines that we're going to use for just this section, we're only going to use the x-axis, the y-axis, and y equals x and y equals negative x. So that, remember, y equals x is just down, like if you have x, y, it's just down the center here, and this way is negative x. Okay, so it's just those two basic lines you're going to reflect across those. And it's the same idea. I can multiply my points by a matrix and I magically get my new points. Kind of a neat way to do it. So let's do some examples of each of these rotations. So let me show you how this works. Okay, so the first example would be just a translation. So what if I have the points A is 1, negative 3, B is 1, 1, C is 5, 1, and D is 5, negative 3. Those are my points. I would like to move it 3 units to the left and 5 units up. So that's what I want to do. What kind of movement is it, left and right and up and down? It is just a translation. So we're just going to add and subtract. So when we're talking left, we're talking moving the x value, right? When we're talking up and down, we're talking moving the y value. So here's how you set up your matrix using your points. You're going to do each point as x, y. And then the next point, x, y, x, y, x, y. So that the top row is your x's and your y's, and you always set it up this way. And we know for this one that I'm going to take row 1, because those are my x values, and I'm going to add, add a -3, because we're going to go 3 units to the left, because we want to go left. It's a negative direction. And we're going to take row 2, and we're going to add 5, because we're going up, and up is a positive direction, and that's going to form my new matrix that is my answer. So I'm telling you what I'm doing so that you can see it in that next matrix. That's a row operation. So if I take 3 and subtract it from each of these numbers, I'm going to get -2, -2, 2, 2. Okay, and for the bottom row, I'm going to add 5. That's going to give me 2, 6, 6, 2. All right, that's my answer. How would I write that in terms of a point? -2, 2, -2, 6, 2, 6, 2, 2. And I don't remember if I graphed this one to show you what it looked like or not. No, I just graphed the other 3. Okay, so I pre-graphed some of them for you. If we look at this, we could list those points out. So -2, 2 is the mirror image. We usually kind of do it with a little symbol of a apostrophe. And then the next point B, or the image of B, is -2, 6. And C is 2, 6. And D is 2, 2. And we could graph these. Let me graph just like maybe A and B, so you get the kind of the general idea of what it's going to look like, and make sure it did the right thing. Kind of show you how it works. So A was 1, -3. So 1, -3 is, here's A. And the new image of A is -2, 2. So this is A prime. All right, so does it look like from this point to this point that we went 3 units to the left? Yep. 1, 2, 3. And we went up 5 units. 1, 2, 3, 4, 5. Yep. There we go. So you just add or subtract for that translation. Let's look at my next example I have here. What if I want to enlarge something by a factor of 3. And I'm going to already list, so I'm going to enlarge something by a factor of 3. I'm already going to list my points in that matrix. So some of your questions will already have the points in the matrix form, and some of them I think just start with the points and you put them in. So 0, 0, I have 4 points here. What would I do if I want to enlarge these by a factor of 3? Well, it's scalar multiplication, so you just multiply everything by 3. So times this entire thing by 3, and we would get what points? Well, 0 times 3 is 0. 3 times 2 is 6. 3 times 5 is 15. 3 times 8 is 24. The bottom row would be 0, 12, 15, and 3. And I did graph these to show you. So here is the original. It went all the way to 24 because I did by 3. So here's my original here, and those are my points that are graphed. And then you can see when I times it by 3, it's 3 times larger with this shared 0, 0 point. Okay, definitely looks 3 times larger. So it definitely looks like we did it correct. So here's my next example. What if I want to rotate something? Oops. 180 degrees. And here is my original. I have a one that's 1, 3, 2. It's just a triangle. So it has 3 points. And I want to rotate it 180 degrees. Well, what did I do? Well, I have to multiply that by the correct rotation matrix. This one here is 180, so it's got -1, -1, 0, and 0. So let's use that. So -1, 0, 0, -1, and we're going to multiply that by our 1, 3, 2, 2, 3, 2. And I have to write it this way in order for it to work, and that's how we use it. Okay, so we are going to use multiplication of two matrices. So this was a little bit harder than just the scalar multiplication. We know this one's a 2 by 2 and this one's a 2 by 3. So remember, the inside ones match, and then the answer is formed by the outside ones, which is 2, 3. So the answer is going to be a 2 by 3, which it better be, because it better get us out those 3 points we wanted. So we're going to take -1 times 1, which is -1. 0 times anything is 0, and add them together to get -1. Then I take the first row times the next, first column. No, row times the next column. I was suddenly confusing myself. -1 times 2 is -2. 0 times anything is 0, so the next one would be -2. -1 times 3 is -3. 0 times anything is 0, so I get -3 for my top ones. Now I move to my bottom row and then multiply it by each columns and then add. So 0 times anything is 0, so -1 times 3 is -3. Next row, 0 times anything is 0. -1 times 2 is -2. 0 times anything is 0. -1 times 2 is -2. And this is now our points, A, B, C, of our triangle, rotated 180 degrees. So I went ahead and graphed these two matrix points right here. So this is my pre, and this is just counting by ones. Here's my tiny little triangle, and it rotated 180. So 90, 180. There it is. And it looks completely right. You can look at your picture and know. Okay, and the last one, let's show one more of the reflection. Okay, so this one we're going to reflect about y equals x line. And so I got to look up which matrix goes with that one. And that happened to have been the matrix that goes 0, 1, 1, 0. And we're going to multiply that by our points. And here's our points that we would have had: 0, 0, 3, -3, 1, 5, 2. And it's the same idea. Our answer is going to be a 3 by 3 again, because we have a 2 by 2 times a 2 by 3. It's going to give us a 2 by 3. So we look at that top one again: 0 times 0 is 0, 1 times 0 is 0. So we're going to get a 0 out on the first one. Next one times the next one. 0 times anything is 0. 1 times 1 is 1. So we add those and we get 1. 0 times anything is 0. 1 times 2 is 2. So we get a 2. Bottom row times each column. So 1 times 0 is 0. 0 times 0 is 0. Add 0 and 0. You get 0. 1 and -3 is -3. 0 and 1 is 0. So we get -3 when we add. And 1 and 5 is 5. 0 and 2 is 0. So 5 and 0 makes 5. Okay, and so this was going to reflect across that y equals x line. So here is the drawing of what it looks like. This is before. This is my triangle with my 3 points. And the line y equals x is right down the center here. Probably should have drawn that so you could see it better here. Make sure I line those up. All right, there you go. Now, can you see that if I folded this not colored in one, if I folded it down that line, that dotted line I just made, could you see that they would line up together and they would reflect each other across that line? Yeah. All right. So there is 4 graphed. So hopefully this helps you with this section.